Okay, for the first problem, it says 7 to the 5th times 4 to the 5th, and to write our answer using an exponent. Remember, I mentioned these in class about how I don't like these problems because they don't follow the rule for the other laws of exponents. This one has different bases, but the same exponent. And so instead of adding, subtracting, or multiplying the exponents, we are going to multiply the bases. So when we multiply 7 times 4, we multiply and get 28 to the 5th power. We keep that exponent the same. For number 6, it says to explain in words how to simplify 153 squared to the 7th power. Now, this is one of the ones that we talked about today in class as well, where we're raising a number to a power. When we raise to a power, we multiply the exponents. So we're going to multiply 2 times 7. Multiply the exponents. And keep the base. Number 7, is the statement 10 to the 5th times 4 to the 5th equal to 14 to the 5th true? Explain your reasoning. Again, this goes back to that first problem that we have here, where we have the same exponent but different bases. If we have different bases, we multiply, and so we should get 10 times 4, which is 40 to the 5th, not 14 to the 5th. They made the mistake of adding the bases instead of multiplying the bases. Now, I'm not going to write out that entire explanation, but you should write it down in your workbook. Number 8. What is the value of x in the equation 5x to the 5th equals x to the 35th? This goes back to number 6, where we're raising an exponent to another power. We multiply the exponents. And so 5 times what number equals 35? And the answer is 7. 5 times 7 equals 35. For number 9, it says, without evaluating the expressions, tell which is greater, 4 to the 4th times 5 to the 4th, or 2 to the 5th times 10 to the 5th, and explain your reasoning. If we solve this problem without solving it completely, evaluating it completely, we can multiply the base numbers because they have the same exponent. 4 times 5 is 20, so we get 20 to the 4th. And then for the other problem, 2 to the 5th and 10 to the 5th, we again multiply the bases to get 20 to the 5th. Now, they do have the same base, but they have different exponents, and so the answer, 20 to the 5th, is greater because it has the greater exponent. Again, I'm not going to write that entire explanation, but you should write that out in your workbook. And the last problem, number 10, it says, Nicholas says that 2 to the 6th times 2 to the 6th equals 2 to the 12th, and also equals 4 to the 6th. Do you agree, and explain your reasoning? So if we go ahead and solve it, we notice first that they have the same base. If they have the same base and we multiply, that means we can go back to our first law of exponents. When we're multiplying with exponents that have the same base, we add. And so we should get 2, and we add the exponents to get 12, 2 to the 12th. So that way this is one of our answers. However, and what we learned today is that if they have the same exponent, you can multiply the bases. And so we should get 2 times 2, which is 4 to the 6th power. And so both answers are correct. Another way to look at it is to write it out completely. If I wrote 2 to the 6th out completely, it would look like this. 2 times 2 times 2 times 2 times 2 times 2. And then again for the second set of 2 to the 6th. From here, we can count up the total numbers of 2, and you'll see that it's 2 to the 12th power. However, we can also group them in groups of 4. 2 times 2 is 4, and if you notice, if we group them in terms of 4, there are 6 groups of 4, 4 to the 6th power, and so both of them are correct.